Let's study delta to star transformation and star to delta transformation of electrical circuits. Star delta and delta star transformation having mapping like this. Select a circuit connection as per the requirement, either star connection or delta connection. Convert the selected connection into either delta form or delta network or star form or star net. See the star delta representation as shown in diagram. The left diagram represents the star connection or star network, and the right side diagram represents the delta connection or delta network. We have selected a common labels as A, B, C for respective terminals in star as well as in delta, and in star net resistances in clockwise like RA, RB and RC. Similarly, in delta connection, we labeled resistances like R1, R2 and R3 in a clockwise direction. Then how to identify a given representation either is in star or delta? If all three resistances are connected in a one common point, then that network must be a star network. And if both the ends of the resistances are connected to other resistances like R1, R2 and R3, then that network is called as delta network. More about star connection. Basic concept. In star connection, starting or finishing ends of the three resistors are connected together to form a neutral point. As we already discussed the same concept, in star connection we are connecting either starting or finishing ends of the three resistors together to form the neutral point. More about delta connection. Basic concept. In delta connection, opposite ends of the three resistors are connected together. Means both the ends of the resistors are connected to the remaining two other resistors in the delta network. Now let's see part 1, delta to star transformation. Next slide. Delta to star transformation circuit representation as shown. In delta, we labeled three terminals A, B, C, and we have connected three resistors as a R1, R2 and R3 in clockwise direction. Here in a diagram, arrow shows that we have to transform delta network into a star network. Here again we labeled a star network as a B, C and connected resistances between terminal A, B as a resistor RA and RB, between terminal B and C as a resistor RB and resistor RC, and between terminal C and A is a resistor RC and RA respectively. Means we have to perform transformation of a delta network into a star network, or we have to perform a transformation of delta circuit into a star circuit. Delta to star transformation procedure. Measuring a resistance in delta connection between point A and B as shown in figure 2a. We have to repeat this procedure for point B and C. Similarly, point C and A. Also see resistance in star connection between the terminal A and B as RA and RB. Similarly, resistances between terminal B and C as RB and RC, and resistances between terminal C and A as RC and RA. Using a procedure of delta to star transformation, equations represented as a resistance between terminal in star equivalent circuit as a resistance RA plus RB, AB in delta network as R2 parallel with R1 plus R3, and in equation represented like this, R2 multiply with R1 plus R3 divided by R1 plus R2 plus R3, or total resistance in equation 1. Similarly, resistance between terminal B and C in star network is equivalent to resistance RB plus RC, which is equivalent in delta network as R3 parallel with R1 plus R2, and in equation form represented like this, R3 multiply with R1 plus R2 divided by R1 plus R2 plus R3, which is represented in equation 2. Similarly, resistance between terminals C and A in star equivalent network is represented like R resistance RC plus resistance RA, which is equivalent in delta network as R1 parallel with the resistance R2 plus R3, and in equation form we write R1 multiply with R2 plus R3 divided by R1 plus R2 plus R3, which is represented by equation 3. Solving this set of equations for RA, RB and RC using equation 1, equation 2 and equation 3 as we studied in a previous slide, we get a resistance value like this. A resistance RA in star network, which is equivalent to a delta network resistances, is R1 multiply with R2 divided by R1 plus R2 plus R3, which is represented by equation 4. Resistance RB in a star network, which is equivalent to a delta network resistances as a R2 multiply with R3 divided by R1 plus R2 plus R3, which is represented by equation 5, and resistance RC in star network, which is equivalent to a delta network resistances, is R1 multiply with R3 divided by R1 plus R2 plus R3, which is represented by equation 6. Then equation 4, equation 5 and equation 6 are representing a delta to star transformation equation. We are using these three equations. We are perform delta to star transformation of a given network. How to remember delta to star transformation formulas? Then here trick to remember. Any resistance in the equivalent star can be obtained by taking the product of its adjacent resistors in the delta and dividing the products by the sum of all the resistors in the delta network. If we place star network into delta network, then resistance array of star having adjacent resistances of delta network as R1 and R2. Resistance RB of star network having adjacent resistances of delta network as R2 and R3. Similarly, resistance RC of star network having adjacent resistances of delta network as R1 and R3 respectively. Then dividing all the adjacent resistances by total resistance of delta network, we get star network resistances as resistance RA, resistance RB and resistance RC respectively. Let's solve the example based on delta to star transformation. Example statement: transform the given delta network into star network. See the delta network diagram labeled as A, B, C with values of resistances as resistance R1 is equal to 12 ohm, resistance R2 is equal to 13 ohm and resistance R3 is equal to 14 ohm respectively. Solution of delta to star transformation example. For solution, refer the formulae from equation 4, equation 5 and equation 6. Now write given data. R1 is equal to 12 ohm, R2 is equal to 13 ohm and R3 is equal to 14 ohm. Using formula of resistance RA of star network as resistance RA is equal to delta network resistances as R1 into R2 divided by R1 plus R2 plus R3. Now substitute values of resistances R1, R2 and R3 using delta network as resistance Ra is equal to 12 ohm into 13 ohm divided by 12 ohm plus 13 ohm plus 14 ohm. Then value of resistance Ra is equal to 4 ohm. We get a value of Ra is equal to 4 ohm. Using formula of resistance Rb of star network as resistance Rb is equal to delta network resistances as R2 into R3 divided by R1 plus R2 plus R3. Now substitute values of resistances R1, R2 and R3 using delta network as resistance Rb is equal to 13 ohm into 14 ohm divided by 12 ohm plus 13 ohm plus 40 ohm. Then value of resistance Rb is equal to 4.66 ohm. We get value of Rb is 4.66 ohm. Using formula of a resistance Rc of star network as resistance Rc is equal to delta network resistances as R1 into R3 divided by R1 plus R2 plus R3. Now substitute values of resistances R1, R2 and R3 using delta network as resistance Rc is equal to 12 ohm into 14 ohm divided by 12 ohm plus 13 ohm plus 14 ohm. The value of resistor Rc is equal to 4.30 ohm. We get a value of Rc is equal to 4.30 ohm. Refer example statement. Star network are represented as using labels A, B, C for terminals and substituting values of resistance. Ra is equal to 4 ohm, Rb is equal to 4.66 ohm and Rc is equal to 4.3 ohm. If possible, draw the star network and label the same using values of resistances Ra, Rb and Rc. Up to now we have studied part 1 as a delta to star transformation. Now let's study part 2 star to delta transformation. Star to delta transformation circuit representation. See the star network terminals labeled as A, B, C and using resistances Ra, Rb and Rc respectively. We have to transform star network into delta network. Again, label the delta network terminals as ABC with a resistance R1, R2 and R3 respectively as shown in figure 2a. Star to delta transformation procedure. Measuring a resistance in star connection between point A and B, point B and C and point C and A as shown in figure 2a. Also see resistance in delta connection between terminal A and B, terminal B and C and terminal C and A as a resistance R2, resistance R3 and resistance R1 respectively. Star to delta transformation equations are represented as equation 1, equation 2 and equation 3. These all three equations we are already studied in a previous slides. Now in star to delta transformation we are referring from the same. Solving equation 1, equation 2 and equation 3 for finding values of resistance R1, resistance R2 and resistance R3 in delta equivalent network as below. Delta equivalent R1 resistance is equal to product of Ra into Rb plus product of Rb into Rc plus product of Rc into Ra divided by Rb of its star equivalent. Value of 2 of delta equivalent resistance is equal to product of Ra into Rb plus product of Rb into Rc plus product of Rc into Ra divided by Rc of its star equivalent resistance. And value of resistor R3 of delta equivalent is equal to product of RA into RB plus product of RB into RC plus product of RC into RA divided by RA resistance star network, which are represented by equation 7, equation 8 and equation 9. How to remember star to delta transformation formula? Trick to remember: any resistance in the equivalent delta can be obtained by taking the product of all its adjacent resistors in the star and dividing opposite resistor in the star network, or value of resistor R1, R2 and R in delta network is calculated like product of all its adjacent resistors in star network divided by opposite resistor star network.